Okay, good evening all. We'll start this tech meet. So tech meet, in Office Automation System Solutions Private Limited, a tech meet it happens once in every month. So my name is Madan Karthisan. I work as a tech lead in this company. So I teach Python, machine learning, cloud computing. We are partners of Microsoft. So I teach courses on Microsoft Azure and also Power BI. So I welcome all the faculty members of SRM and DMI and also the students from SRM and also our people who have taken our courses, all the members and our employees. So thanks for this opportunity. So in this, I'm going to talk about what is our company doing. So Object Automation System Solutions Private Limited, our company is headquartered in California. This is our development center in Chennai. So we do three things. One is training various people, students, working professionals. Education is one thing. The other thing is projects. So we do a lot of projects on AI and chip design. The other thing is establishing centers of excellence. So we are setting up various servers, hardware, software for universities and colleges. That is called establishing centers of excellence. So the last few years, we have established tech centers of excellence in Shastra and NIE, National Institute of Engineering, which is one of the oldest colleges in Mysore. So I'll just go through the object automation perfect. So what we do in I have a PPT. In this, I'll explain about what we do in our OA. So here, if you can see, this is in addition to our object automation logo, we also have two other logos. One is the University of California, San Diego. So we know in universities in US, there are a lot of campuses. So our CEO is a distinguished faculty member of University of California, San Diego campus. So apart from that, Open Power. So Open Power is a non-profit foundation from IBM. So our CEO is a 30-year veteran of IBM. Now he is the president of Open Power Foundation. So I'll explain about what does Open Power does. So these are the three things we do. Okay. So as I said, we're dedicating our things to research, solution development, and establishing tech centers of excellence. So this is our development center in India, and headquarters is California. So mainly we do two things: AI and chip design. Okay. So this is the Open Power Foundation. So this is a non-profit foundation from IBM. So this is mainly for engineering students from ECE, EEE. So people they want to do chips, so design chips, fabricate chips. So for this, the organizations. So now we know in India we have the next 20 years it is going to be AI, quantum computing, and chip design. So now you know a lot of companies are investing in India. Like recently in Gujarat also, a manufacturing plant is being established by Tata also. So now there are a lot of job opportunities and vacancies for students of EEE, ECE, mainly with related to chip. So for this, we are also we have chip design engineers who take course on chip design. So what you can do is you can become a member of not Open Power Foundation. Any student of ECE, EEE, or any organization, they can become a member of Open Power Foundation. That way, they will be given access to open source tools. Like currently, there are some paid tools like Vivaldi, there are some paid tools which are costly for to procure by engineering colleges. So what we suggest is students can become a member of this Open Power Foundation. That way, they can utilize this open source tools. So these are the three things they can do. So one is they can build their own custom hardware or systems. So ISA, instruction set architecture. So these are things they can do. So there are something like microwatt. So you can create projects like microwatt. You can build system on chips, SOC. So all these things can be done by becoming a member of Open Power Foundation. Mainly this is for EEE students, EC students, or those industries who are dealing with chip. Okay. So our company started in 1996 by doing Unix projects. So currently we are doing projects on chip design and AI. From AI, from 2011 we are doing projects on AI. From 2017 we are doing projects on chip design. So mainly we focus on quality, technology solutions, and client relationships. Since here the audience, most of the audience are from faculty members and students, I'll just talk about this last vertical. So here you have 5 different verticals. I'll talk specifically up to about offers to universities and colleges. So as we set up center of excellence. So what is a center of excellence? So universities, colleges, they require hardware, software, lot of things for the students to learn. So like for example, a lab. like a computer, a server. So these things we procure from various vendors. We are partners of Dell, HP, Microsoft. So we from the vendors we procure them and we sell to university and colleges. That is the first thing we do. Then we conduct faculty development programs. So there is a big gap between the what industry requires and what student needs. So to fulfill this gap, we regularly conduct faculty development programs. So for FDPs, we bring resources from not only from India, but also from abroad. So we conduct online FDPs, in-person FDPs, on-campus FDPs. So a lot of different types of FDPs we conduct for the benefit of faculty members, whereby the students get benefited. Then training programs. So we are conducting a lot of training programs. So students come here mainly in the month of May and June. So you may be knowing another city requirement is they have to fulfill an internship. So people come here for 14-day internship, 30-day internship. They do on cloud computing, cyber security, machine learning. So these are things we do. Then we are sending students to US, Europe. So people who finish their undergraduation and when they want to pursue post graduation like MS, MTech, we are sending people to US, Europe. We are guiding them. So in which university you will be getting based on the CGPA, based on the TOEFL score, GRE. So all these things we will guide them. So these are the three offerings. So these are three offerings we do. So technology enablement, onshore, offshore development, research solutions. So these things. Yeah. So with respect to technology enablement, I told you here. So these are the four things we do. So in-person, on-campus training. So students come here for in-person training, and also we go to various universities and colleges and campus. So that is on-campus training. So tailored to the institutional curriculum. So each university, each college may have a different curriculum to cater to the needs. We go to the on-campus and train them based on the curriculum. And workshop. So we conduct regularly short-term workshops, 1 to 5 days. Then Global AI Chip Design Conference. So August 15th also, we conducted a Global AI Festival in SRM Ramapuram. Then order and software setup. So 1 hour a university requirement is there. Based on our hardware, software, we procure them. So we have next thing is onshore, offshore development. So we do a lot of projects. So these are three main projects we do. So there's an AI resource, HPC, high performance computing resources, chip design verification. So we have engineers on all these things. We are doing in-house projects. So these are the two research solutions, AI and chip design. So these are our international key collaborators. So these are all college universities located in United States. So University of Oregon, Ohio State University, University of Wisconsin. So Quantum Ventura, we have tied up with Quantum Ventura and also XScale Solution. So XScale Solution is a company which provides HPC software, high performance computing software. So these are our international key collaborators. So people they do GenAI course here. So we give them access to University of Oregon. So we know for machine deep learning GenAI, we need to have large amount of processing capability. So we have to have a server level capability. So for them, who students who are doing GenAI courses, we give them access to University of Oregon. We are tied up with University of Oregon. That way we are providing them the access. So these are some of the institutions. So we are signed up with SRM Ramapuram, DMI, LIT. So these are some of the institutions we are signed up. So not only from Chennai, it is also located from other districts of Tamil Nadu and also other states of India. So you can see New Horizon, it is in Bengaluru, NI is in Mysore, then you can see PSA is Dindikal, then JNQA, Jawaharlal Nehru Technology University, Anantapur. So Andhra Pradesh, Karnataka, so and also Gujarat also is Vadodara as a university. We also signed up MOU with them. These are some of the key collaborators. Okay, so now I have faculty members from DMI. So currently we are conducting this IBM Career Education program for students of DMI. So this is open to all the engineering students. So what is the benefit of IBM Career Education program? This is an 8 semester program. So we know any BTech or BE course, it is for 8 semesters. So IBM, apart from what they learn in 8 semesters, the curriculum framed by University, this is curriculum framed by IBM. So IBM, like you have specialization like cyber security, cloud computing, blockchain, big data, AIML. So for example, I talk about AIML. So the first semester they will be learning about Python, second semester they will be learning about Java, then big data analytics. So every semester they will be learning a course from IBM. So we are the collaborator for this course for IBM career education program. So our members go to DM, for example, DMA professors are here. We go to DMA every semester, maybe about 5-day course. We provide the what is the benefit of this? The students get certificate by DMA as well as from IBM. So when they go for when they go for placement, so in addition to whatever B certification they get from another city, they also get this co-branded certification. So whatever is the current, so it's because of IBM. So IBM is providing all the hardware, certification, content, all these things. Scope of certification. These are the key features. So here you can see AI. So AI requires a lot of processing capabilities. So storage capability, processing capability. So this is provided by a Power AI. So you can see a Power AI is nothing but a platform, and it runs on IBM Power System. So so you can see AC922. It's a server. So when you want to do deep learning Gen AI projects, we need to do parallel processing. We require high performance computing. So this Power AI platform and IBM Power System. So both with this help of these two, we are able to do this deep learning machine learning projects. So these are the special courses we do in object automation. So most of the courses it's hands-on, so it will be around 40 hours. So we do in person, on campus, and also offline. So people also come here. So we do various weekday courses, weekend courses, after office hours courses. So we provide them. We are very flexible. So see, these are the softwares. So these are Xscale. So Xscale is a company which has done this software, E4S. So this is mainly used for high performance computing. So when you do high performance computing, you require this software. I told you Xscale. So this is a company which has collaborated with Ohio State University. Okay. So in the very first line is a open OIA logo, Open Power logo, and UC San Diego logo. So we also provide teaching to students of San Diego campus and University of California. So this is year one plus one site data science course. So apart from that, we also conduct various courses for University of California students, San Diego campus. So our CEO is a distinguished professor in San Diego campus, University of California. Okay. So these are our contact details. So our website is www.object-automation.com. So these is, you can note down these contact numbers. Okay. So as I said, in the next 10 years, 20 years, AI, quantum computing, and chip design. So there will be more opportunities for the students and also for people who are working on these projects. So any questions you have? So I just gave a brief introduction about what object automation does and where is the company located, all these things. So these are here you have Kirpanadi and Jagan. They are all chip design engineers. I have with me Gen AI engineer, and we have our business development manager Surika. Any questions you have? So now I request Rahul. So Rahul will be talking about Gen AI and now what are the current projects we're doing on Gen AI. He'll be giving me a brief demonstration.
So good afternoon all. Yeah, we basically know that traditionally software engineering, it used to be based off predefined logics. We define different functions to make every function run. So from there, like the whole computing world shifted from predefined logics to uh, Gen AI, like IAML, like machine learning and deep learning. Then from there, it shifted to Gen AI. You guys may know familiar with tools like ChatGPT, Gemini, Claude, right? So these are like tools which can generate you new content. Like it can be either text, code, audio, video, like any form of content. It can generate you in new format. Okay, these tools, like they are just a question and answering like a tool. They cannot perform actions, make decisions, right? So that's where it shifted to agentic AI. So you can set up a signal agent system or a multi-agent system, like which can plan, make decisions, and go towards your goal. Okay, and from there, like there are n number of possibilities. From there it can grow to. So like I added like one of the important thing, which is edge AI. So like we will now discuss that about into the session once we go into the session. So the paradigm shift. So as I already mentioned, um, before it was a role-based logics, right? So from there we had machine learning. So where we will be giving like huge amount of data. So from there, machine learning, like supervised or unsupervised learning algorithms, using those machine learn the patterns. From there, it will be predicting your new outcome. So after that, we had deep learning. So with deep learning, it gave us neural networks. So using neural networks, it helped us with advanced learning concepts. So over there also we can use both structured data and unstructured data. So using them, um, we can make the systems learn the pattern in a more advanced concept. Okay, so from there we shifted to Gen AI. So Gen AI, it basically helps with next token prediction method. Okay, so as of deep learning, it can only predict you the missing token. Okay, so Gen AI helps with predicting the next token. So that's how your answer is getting generated in terms of using ChatGPT or Claude. Okay, so because of this, you can see the highlighted industries which are transformed. Like in most of the industries today, like AI has been paired up with something. Like in software engineering, it helps you with coding, debugging, and with cybersecurity, it helps you to identify threats. And with healthcare, where you can diagnose patients, report like past history, and guide them to the doctor. So likewise, in every industry, AI is performing some part. Okay, so after Gen AI, so we are moving on to the agentic AI, which I told you, like where you can make like tell the system to make decisions on its own and do your goal. So if I tell make me a website, so it doesn't gonna ask me like shall I do the website. Okay, so on itself, these agentic AI are gonna go and do the task. At last, it's going to give me the outcome. So that's how agentic AI works. Okay, so after that, we are moving to autonomous or multi-agent systems. So as I already mentioned, we can set up either a single agent system or a multi-agent system. So in multi-agent system, we will be having multiple agents. Okay, so each agent can perform its own task and they can collaborate with each other. They can communicate with each other. So there will be no communication error. So they can orchestrate the whole process. From there, they can move towards the goal, whatever it is given to them. So from there, we have autonomous like vehicles nowadays. Okay, yeah. So the power and the ceiling of generative. So power in the sense, what is powering you the outcome. So whatever the outcome you get in terms of text, uh, code, or anything. So what is powering them? So whatever happens inside this LLMs, right? So they are calculated in terms of token. So token in the sense, let me say AI is powerful. So the sentence AI is powerful. Each word will be divided into each token. So AI will be one token, S will be one token, and powerful will be one token. So now the ChatGPT, whatever the model you are using, right? So it has whatever the flow you have with the conversation from the question to the final output, it all calculates in terms of context window. So the ChatGPT 4, it has a context window of 128K tokens. Okay, so where it is roughly around 96,000 words. Okay, so it can maintain the conversation flow up to 96,000 words. Okay, and embeddings. So all these LLMs cannot understand words. Okay, so in terms of sentences, we need to convert them in the form of numbers. Okay, so that's where the embeddings comes in play. So we have something called embedding model. Okay, so what it basically does is it converts your sentences into numbers and represent them in the form of vectors. Okay, so that the machine can understand them easily, and when it is processing them, it will be more easier for them to retrieve the content and generate them. So after that, we have retrieval augmented generation. So you might have heard about chatbots, right? So nowadays, most of the chatbots, they use this architecture called retrieval augmented generation. So it basically whatever the local storage you have, like your details about your organization, anything. Okay, so whatever you stored in the local storage and in terms of your website or from wherever, you can retrieve those contents, that extract them. So, and from there you can process them. Like you can extract those content, clean them. Cleaning in the sense you need to remove the punctuations or commas, like whatever text pre-processing. Okay, so from there you need to perform chunking. So chunking in the sense, like you are extracting a whole paragraph, okay, from any document. So if you give the whole paragraph to the AI systems, it will be very hard for them to get the whole context of the whole paragraph. So what we need to do is we need to split them into off, or based upon your input data, we can split them. Okay, so that the AI systems can process them very well and get the context of the whole paragraph very easily. Okay, so from there we will be moving to embedding model. So embedding model will help you to transform those paragraphs in terms of numbers or vectors. So after that, we will be storing when it comes to Gen AI or agentic AI, we will be using vector databases. Okay, so using these vector databases, they will be visualized in terms of dimensions. Okay, so all this processed embedding data, they will be stored in vector database. So from there, whatever the question you are asking to the chatbot, it is going to retrieve them and it's going to be sent to the LLM. So from there, you will be having an output. So that's how all these chatbots are working these days. So the ceiling. So ceiling in the sense which can bring down your outcome quality. Okay. So one is hallucination. So when your LLM model doesn't have appropriate knowledge regarding your question, it automatically generates an answer on its own. It assumes that whatever I'm telling, it is going to be right, but it will not be relevant to the question. The hallucination can be defined defined only by the human. Like we need a human in the loop to detect them. As being human, we know what is correct, what is wrong, so we can detect hallucination. Okay, and another thing is limited reasoning. So LLM models they train them batch by batch. So let's take now we are using ChatGPT 5. So it may have limited knowledge cutoff. So let me say it will be trained till 2025 December. I'm telling in terms of an example. Okay, so it will be trained with the data whatever it is available till December 2025. So if I ask what happened on January 2025, it doesn't have a knowledge. So in that sense, it can either hallucinate or it can say, I don't have the prior knowledge to your question because I have my knowledge cut off. So these can be few things which can bring down your output quality. So next is these generative like LLMs, they do not have decision making capabilities. So they will be asking every question to you, whether should I do this, shall I do that? Okay, so after that, it doesn't have a good context memory. Okay, so as I mentioned, it only calculates in terms of context window. Okay, so for every model, it differs. The context window differs. Okay, after that, so your chat, like whatever your chat flow, you cannot take it to the next session. Only if you take that context prompt, you can take them to the next session, or else it cannot. And it cannot remember your past interactions also. All these LLMs. And yeah, so let us see the difference between Gen AI and agentic AI. So all these Gen AI, right, they are more static question and answer kind of a tool. And agentic AI is a dynamic, and it can make decisions on their own and move to your it is more goal oriented. Its only sense is to finish your goal, whatever the goal you're given. Its work is to finish them. However, like using the capabilities of LLM, it is the only goal is to finish your task when it comes to agentic AI. And this as I mentioned, LLM has like a limited context, and with agentic AI we can pair them with like a short-term memory or a long-term memory, so which can be used for remembering the past interactions of your, like you can store your chat history, and using them like we can with the help of agentic AI systems we can continue the past interactions on the flow, so which cannot be done in the LLM. And LLM basically no, they perform on next token predictions. And agentic AI, they can pair up with different types of tools, API, databases, and like we have you might have heard about the connectors in terms of ChatGPT or Claude. So you can connect them to different tools, and from there you can do your task by connecting to different applications. So the anatomy of AI agent. So one I mentioned is it is goal oriented. So whatever the task you give, the only goal, like only motive is to finish that goal and give you the output. So another thing is planning. So whatever the steps that are taken to complete your process, all that are logged, and it will be shown to you like what are the planning steps are taken to complete this specific task. And next is memory. So memory in the sense we can pair up with long term or short term memory to remember past interactions, or like in terms of whatever your workflow is needed, you can do them. And tools usage, like you can connect them to different databases, and like API you can use them for weather calling, and like we can also use them in terms of calculating credit risk. So we have many use cases when it comes to tools. Using agentic AI we can do them. So yeah, so the agentic infrastructure stack. So the application layer. So that is where your required libraries like LangChain, LangGraph, Pro AI. So whatever the agentic libraries, they are going to be staying in the application stack. Okay, so after that we have the cognitive layer. So cognitive layer in the sense that's where your LLM, the brain of the agentic AI, is going to be living. So either you can get your LLM from through a API key, either it can be from a paid service provider from OpenAI or Claude, or you can also get from OpenRouter, Grok, Zebras. Like these are no free LLM providers through API key, and we have Olama or LM Studio. So using these Olama and LM Studio, you can run your own, like not a own, like open source LLM models locally on your laptop. So after that, we have memory layer. So in the memory layer, we are going to have two things. So one is the vector database to store all your data, uh, and the memory context. So whatever the interaction you have with your agent, to store them, these two are going to be staying in memory layer. And ops and deployment layer, so it's going to have Docker, so whatever the cloud service if you want, so all is going to be now laying under this ops and deployment layer. So enterprise impact matrix. So we already saw some use cases. So in terms of software engineering, it is used for coding and debugging, and cybersecurity to detect threats and SOC copilots. And when it comes to finance and HR, so these can be helpful in generating like reports and what, or if you want to make any dashboards with the financial data, it can help with that. Okay, so these are some of the use cases. And even like nowadays, every industry is trying to cope up with AI, like what can be done with AI with our organization. So that is the goal of the all the organizations today. And day by day, a new use cases emerging. So the evolution of AI talent. So first, when like this Gen AI like started to emerge, there were less number of roles, like prompt engineer. Okay, so once it started to evolve to agentic AI, so we have now we have n number of roles: applied AI scientist, AI product developer. So n number of roles are there nowadays. Okay, so from this, the industry is shifting from like normal roles to AI developer, AI product developer. Like one is going to be building LLM from scratch, and another one is going to be building products using these LLMs. Okay, so there are n number of roles nowadays. So next is like what is like I have mentioned about this agile. So what it is going to be basically. So here we have a FPGA board. Okay, so what we are going to do is we are going to FPGA board. So yeah, we will basically explain now. Okay, so like we are going to boot this FPGA board with Linux. Okay, custom built Linux. Okay, so inside them we are going to run with LLM model. Basically, we actually done that. We are able to use LLM model inside this FPGA board, which is mounted with the SD card, and it doesn't have a much much RAM memory also, but we are able to run LLM model to AI inferencing. So where like AI will be running in some server, any either a local server or in some cloud service. Okay, through that we can make inferencing and able to run LLM models. So from there we are moving to adding sensors. So using sensors, we are trying to make predictions like object detection. So from there we are trying to move from there. So why do we need to do this? Is that the energy consumption. So like wherever we use cloud services today, which costs us like the energy consumption is higher when it comes to cloud services. Okay, so using this FPGA board, the power consumption is less. Okay, and you will be using LLM which are running locally. Okay, so your API bill is going to be lesser. Okay, and it doesn't no it doesn't want to have a proper electricity. Okay, like it can no the LLM model can run locally, so it doesn't need that much electricity. And when it comes to cloud, we have to send data from our local system to the cloud service. So from there, it makes all the inference and it comes back to your local system, right? So using this FPGA board, we can overcome that. We can reduce the latency of introduced while doing all this inferencing. So using this FPGA board, we can reduce them. Okay, and yeah, so this is what we did. Like in terms of hardware, we have paired up with soft CPU micro one. So and we have booted up the Linux. Okay, so inside that we are able to make all the AI inferencing like ML predictions, running LLM. So now we are trying to run a deep learning model for object detection using camera. So likewise, it is moving step by step. Okay, and when you are using these FPGA boards, your data, it doesn't go anywhere. It all stays in your board itself. So there will be a privacy in your data. Okay, so what are the use cases that can be done using this FPGA board? So we can use it for drones, any autonomous vehicle, in terms of military, and in terms of healthcare, and like there are now many use cases which can be done using this AGI. So we started from Gen AI, like which only generates your data, and after that we moved to Agent AI, like which helps you to do your task, and AGI, like it reduces your power consumption, and from there, no, it can go into many number of ways, like artificial super intelligence or artificial general intelligence. So there are many concepts nowadays, in terms of research, and they can, like emerge like suddenly, and people will be moving around that. Okay, so do we have any questions over here? Any questions? Any doubt? Yeah. Sorry. Yeah. 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 Gen AI is what is helping you to generate all those contents, like video, audio, text. In any terms of new content, Gen AI, like whatever, like in the term of Gen AI, the LLM model, the whatever tool using, ChatGPT or Claude, they are running by like a model called LLM models. So all these models, right? They are like whatever the data like available around the world. All these company like OpenAI, Claude, they're going to gather them, and they will be performing training these models with them. So while training, it tries to understand the pattern. Okay, and after that, once it is not done, like many testing will be done, like guardrails, like ethical safety. So it need to pass all these tests. So after that, they will be doing whether like based upon the learned pattern, is it able to generate new content on its own, on its pre-trained knowledge. So that's where you are getting your new content, like in terms of video, audio. Okay, so one model, generating many content, it is known as multimodal LLM model. So one model can generate audio, video, text, code, all these kind of use cases one model can do. So it is called as multimodal LLM model. Sorry.
It is calling you. You must be, Okay. So meanwhile, while Raghu is explaining to the professor, I'll just give a brief introduction about. So like Gen A, it consumes a lot of GPUs. So like we have tied up with University of Oregon. So that infrastructure is provided by University of Oregon. So people who do course in object automation. So people are doing a lot of courses in Gen A. So we are giving access to University of Oregon. So we have a server, GPU server. So the student can use the server. So this is not an easy thing. So most IT training institutes they do not offer this. So this is like one thing. So like it's very bad. So we are providing this access, GPU access. So we are tied up with University of Oregon. So apart from that, we are partners of Microsoft. So we are conducting a lot of Microsoft Azure courses. So like okay, for data engineering, for that's something called AZ104. So the knowledge of cloud computing is essential these days. So like what is the storage account? So what is a virtual machine? So there are a lot of resources available in Azure. So we'll be conducting these courses hands-on. So they can create a storage account, they can create a virtual machine, a Windows virtual machine, a Linux virtual machine. So all these things, basic things of cloud, we'll talk about 40 hours. It's a 40 hours will teach, and also certification they can take from Microsoft. So you have to pay 4,860 to Microsoft, they'll get a certification. So when they go for placement during the final year, this will be very useful. So I'm just giving an input. And also people come here for internship. So internship also reporting on cloud computing, data visualization. Since we are partners of Microsoft, we are teaching Power BI. So Power BI also we are teaching for 1 year. So maybe from arts and science. So people they want to become a data analyst. So Tableau and Power BI these are the two BI tools, business intelligence tools. So the knowledge of this is very essential. So those days Excel, now advanced version you can say BI, Power BI. So whether they're going in Power BI or not, they're going in cloud computing or not, at least 15 hours of learning Power BI, 15 hours of cloud computing is very essential. So that we are providing. I just want to add in the meantime. Can you speak for 5 minutes? Yeah, just give me a look. I'll ask. So, anything. So in the meantime, I'll ask all the guests to come and talk here. Please come. So I'm inviting the SRM professor to talk a few words, and we can stand here. It's a YouTube version.
Good evening, everyone. I am Shakti Ashwini, Assistant Professor at PG Department of Computer Applications in SRM University, Ramapuram. And this is the first time I'm coming for this technique. And so far, I have used GenAI tools, but this agentic AI is new to me. And he talked about the HAI also. It's very new, and I think it will be useful for everyone. Yeah. So, I think what is these tools we have?
Authentic way. So he knows more information. Yeah. So no, mostly we use universal organ server. So we put a lot of parallel processing. So you log into the universal organ, GPU access, like deep learning, all these things requires a lot of computing power. So use we use I think so Claude uses Claude. But we use Claude, all these things. You know this. You give me more information. Thank you. Thank you. So thank you, ma'am, for your feedback. So I called Abhishek. So can you share a few words? So Abhishek is an employee of Formula Mission. So he worked here for a few months. Then we'll talk about so what is your experience? Yeah, please tell me. It'll be recorded.
Yeah, thank you. Good evening. So myself Abhishek, I am currently working. Currently I'm working as an associate in Cognizant. So basically, I was working in Power BI and data engineering projects in Cognizant. So before going to Cognizant, I was working here as an AI support specialist. So the things that I worked on after automation is machine learning, deep learning, and building a that dashboard in Power BI and HPC and also web development projects in public automation. So here I was worked for 1 year 7 months. So with that experience, I shifted to Cognizant. There I am working on multiple projects on Power BI. So the areas that I worked on Power BI is development, AMS, which is the application maintenance and support, and also the migration project in Power BI. So the things that I work in Power BI is development of the reports from the scratch and fixing the data-related bugs happening in the existing reports and delivering the report, dashboard, and the data model files to the customer. Customer in the sense is stakeholder. So the delivery part of the report is somewhat complex that we have to make sure the report should not be volatile and that the data configuration should be secured. So these are the few things that we need to make sure to deliver the report to the customer. And apart from the Power BI and the front-end reporting, I also used to handle the data engineering pipeline as well. So the data engineering objects and the application that I used to work is I was working in Oracle Stack and as well as in the Microsoft Azure and infrastructure as well. So as we have a talk related to the GenAI some time back, so you may have a question like in business intelligence part, is there a usage or a utility between this GenAI is there or not? So I would say like absolutely we also use GenAI tools like ChatGPT, Claude like that. So like what are the things that you will do with the help of this GenAI in your scope of work is? So as I said, I will be dealing with this data engineering pipeline, right? So whenever the data engineering part is nothing but transferring the data from the source system to the target system. So this data transfer process is a bit complex. So as a terms we can say it is a data engineering pipeline. So in a word, it is a bit simple, but when it comes to a process perspective, it is a complex process. There, the data transformation undergoes a multiple process like storing the data in staging and delivering it to the target system. It takes multiple process. So whenever the causes of failure on the system will occur frequently. So to overcome this, we use GenAI tools how to overcome this problem or the issue and how we can fix it permanently like that. So apart from that, we used to take care of the delivering the data from the not only from the source to the target and in between the staging tables. We used to check how we can optimize the query to deliver the data even more faster, right? And also handling the data in the data warehouse, those things and all we used to check with an AI tool. So like now, so as we also use I conclude my talk like we also use AI tools to optimize the system and to prevent the and also prevent the issue happening on site. So if you have any questions related to PA or data engineering, you can ask me. Can I take this silence as a no questions you have? All pretty good. Okay. Thank you. Sir.
Thank you. Thanks. Very good. Okay, thanks, Abhishek. Yeah, please. You want to ask him?
I'm an English teacher. I've been asked to attend this meeting because I have a habit of motivating the students to learn a different, not only the language, English language, that's also the languages and that. That's why management might have asked me to attend this meeting. I always motivate the students to learn new things. But my point is it's a general aspect. For example, the last sentence itself, it says that's good. The future is not just AI that answers. The future is AI that acts. That's fantastic. I'm able to understand and grasp the point. What I feel is because most of the, for example, in a college, the college has 1,000 students in the first year classroom, first year. Around 650 students are the computer science related students. Remaining that 350 only the core engineering, mechanical engineering, civil engineering and all. No, this is technical aspect. I'm just asking you. If it happens so, the future is AI that acts. What about the future of these guys? I'm just asking.
You're asking about the people, students who are taking core. So, core engineering, like civil, triple
It's
E.
not core engineering. So the students, the job of the human being will be done by the AI. It is not only answering; it start acting. So if it does so, what is the necessity of the engineers or these programmers? Do you need this much of programmers to serve the society? If this itself does the job, what is the necessity of our existence? I'm just asking. No,
Yeah.
I'm not expecting you to answer this. Just happened.
Your opinion, you're sharing your opinion, I understand that. So it is helping the employees also. Like everybody is using AI tools. So if you don't, for example, coding, you won't write coding for any full stack website. We have spent on more than 10 hours previously. Now with the help of AI, they're taking the code in 2-3 hours. They know that, but they have to know the concept. So for example, English, I know that the mother-in-law, you have to put hyphen. Some people then and before and we don't put in India. A comma B comma and C we don't put and. You can see here reasons comma and ups. We know that it has to be taken by US. So we don't put before and we don't put comma, Oxford comma. So like this, they have to know. The students have to know mother-in-law. I have to put mother -in-law. Just like that, they put sentence in ChatGPT, do a spell check, grammar. It will not be useful when they at the point of interview. So they can take the help of ChatGPT or anything, but they have to know what is this coding also. They have to know the syntax. For example, English, I told you. So what is the pronoun? Those things, hyphen, where should you put hyphen? Where should you put possessiveness? They should know. It will give you the grammar, everything goes spell check. It will give you a beautiful thing, what do you call essay. So I'm also using that. But we have to know what is that. You have to know to understand. Somebody has questions you have to explain. Maybe I can take the content, but I have to explain. So he's taking the content, but he's explaining. That is what it is. It saves his time. So he can, so remaining time he can spend in some other activity. So instead of thinking about this, he can put this in another project. So it is helping definitely people. Like the 97, they said when computer comes, everybody is going to lose job. It did not happen. So computers generate a lot of jobs. That is also one way. So if both ways are there, but definitely there will be some job losses. I understand. So that you can see every company is getting a layer, doing layoff and all. I understand that, but we have to go with the flow only. No other go. Yeah. So now continuous learning is essential. Whether you are 50, 60 or 40, continuous learning is essential. That is what I tell all people. So there is no safety zone and all. Comfort, discomfort you have to be.
It seems nowadays there are so many layoffs. If it happens, so if a particular company, a particular project, if they need 100 people, only 5 people can do this, and their remaining work can be done by this basic or this
Yeah, so the percentage of, we don't need so much of people. Previously 100 people is now 20, 30 people we can do. Understand that? Yeah, that is how the situation is. Thank you. So you can share your motivations, sir. You can come here. You can speak for me. I'm investing. Yeah, please share it. Yeah, please come here. So I request you, sir, please come. What's your name, sir? Good name? Good name? Please, I request you, Professor Jay Shankar, to share a few motivation on, yeah, you can share his thoughts. So you can stand, if you're doing your YouTube videos, you can stand. Near the notes.
Good evening to one and all present here. First of all, I'm happy to attend this workshop because we have taken initiative to impart the knowledge to the teachers and the students. It is necessary to build the society. The purpose of engineering is to comfort the society. So but nature will take its own course. I myself asked the question, and I am answering for that because so many students are studying this, for which nature will take. God will take care of that. But we will have to update it. But taking this initiative to impart the knowledge to the trainers, that's the teachers, and that is necessary. We will have to update it, that I am able to understand. That occurred in my mind when I was listening to it. It occurred in my mind, so I asked that. Of course, it's a wonderful workshop, and we'll have to understand this. So there is no other option. We'll have to update it, whether it is in the software industry or whatever the industry. We'll have to update it. For which you have taken this initiative, it should be appreciated. We'll be thankful for your deeds. Thank you.
So thank you for the kind words, sir, Professor. So, I request Kirmanaji to talk about chip design.
Good afternoon, everyone. So today I'm going to share you about like what we are doing in the chip design industry. So how many of you from electronic side? Have any? Okay. Like what we do is like since like if you come across like we have a processor called the microwatt, which is an open source processor. Like have you heard like when Madan sir has teached about the open core foundation? So from those foundation, like we have some open source architecture. Currently, if you see right now, like all the countries they are into like making their own chip. So for that, before few years back, and all those architectures that were the chips were making the large industries like Intel, Qualcomm, they keep their architecture as encrypted. So right now, like we are moving into the more open source one. So everybody can now the students and researchers can enter it and then they can create their own chip out of it. So as a part of that, the Open Core Foundation has come up with a processor like called the Microwatt. So the Microwatt is an open source software CPU processor which is written in VSTL, similar to the kind of language like what we use in Python, C++. Likewise, for this hardware coding, we have some different types of languages called VSTL, Verilog, like that. So, like this processor has been coded in that language called the VSTL, and it has been implemented on the architecture called the Power ISA, that is instruction set architecture. In the modern days, like yes.
Excellent theory, but font to the color rate font theory. either the the font
Yeah. So that is what I discussed about the Open Core Foundation. So it is created in the year 2013 from the IBM and all. Like where they currently have these architectures like the Power ISA. So which is similar to this ARM x86, like what we use in the current laptop, which is being closed source. So with the open source like from the Power ISA, they had developed a processor called the Microwatt, which is so from there where we just boot Linux and run the AI programs like what Rahul has told. Like our goal is like so this has been available from the GitHub. Like you can get the whole processor code like how it has been coded. So from there that you can get the code from the GitHub, and like you can flash it into the real hardware, like this, which is called this FPGA board, which is field gate programmable array. This is like a actual chip, like ASIC chip. That, but the use of this FPGA is like we can reprogram it number of times, unless like the ASIC chip. So like when you come into the industry, like before we try to implement the code into the actual chip, like we used to test it with this type of FPGA boards, and like we just check how the process works. So once if it get works, like we can move into the actual ASIC flashing the chip. Then like this is what the microwatt processor is about, like what the pipeline. So this microwatt has been works under the pipeline structure called the you can see the pipeline like stages like fetch, decode, execute, memory, write back. So each architecture has been works under the specific pipeline, like how this will start and work. So where the fetch is like it will fetch the instruction like from that input, and it will decode like what type of instruction it is, like whether it is an arithmetic logic unit or what type of instruction it is. Then it will move to the execution stage where the actual execution takes place. Then the memory and the write back where the memory where it gets stored the memory to the respective registers and all. So that's how this basically the microwatt has been worked. And this has around 32-bit general purpose registers, and it has around the 64-bit architecture. Then it also supports full SoC. So the microwatt is just a CPU processor, but here we also baked it as a complete SoC by adding some peripherals that you want like to this microwatt, and just we have developed it into the complete SoC. So a complete system on chip where that one chip can control the whole system. Then like so it's what like end-to-end flow, like what we teach here. So from the I say like what are the architecture, the instructions that what we did. So how this code has been written. Then we move to the main RTL design, like where RTL design is like register transfer level. That is like the code from the gates to the actual coding to the hardware coding. So that has been currently we deal with two main programming languages like Verilog and VSTL. So with those, like we design the basic RTL coding. Then we just move into that. After we write the code, like we have the next step is like the simulation. So all those things that we cover from end to end, like with an open source tools like running license. So from this RTL to the FPGA prototyping, like we use the tool called Gado. So using the tool, like we can write the code and like test the program. Then the simulation is like where we test the program, like how it has been written. So where like by giving some sample test cases to the program, the processor, like, and we just test with the waveform, like how it has been working with the help of the simulation. So for that, like we have several tools that has been available, like CocoDB, which is also a Python-based verification tool. Then as once we just verified with the software side into the simulation, then we move into the hardware part to verify the code, like as I said, the FPGA. Then so once the front end part has been done, so once we write the code and then we test it into the hardware, like we just move into that, creating it into the actual chip. So that's what, like creating the layout, that is what about the physical design. So this is like, as I said, the first step is like ISA definitions. Then the RTL design, like where we return code, and then simulation. So where here for this VSTL, we use a tool called VSTL. That is like a simulation tool to verify the code. And then Verilator, that is for Verilog code, and the GTK waveform, like to test the code. Then as I said, like FPGA prototyping, like we have the code called RTK700 code, which is we used it for verifying this in the FPGA prototyping. Then like we also have the board, because like since like the students all can buy and use this board, like just being costly. So we also have the similar board which has been available in the server also. Like we have been tied with the University of Oregon server from the US. Like, so we have the FPGA that has been available from the server, so anyone can like try login to the server, and they like as I said, the tool like what we used the Vado, that also been available in the server. Like anyone can log into the server, and then they try the code, and then they can test with the FPGA board. So currently there have been around 5 to 6 FPGA boards that has been available in the server. Like you can try and test it with the some login to the server. Then like I come into the the backend flow, the physical design flow. So these are some of the stages to generate the chip. So at the right hand side, you can see that is the final layout that what we have generated. So the layout that is like a architecture, like how we construct a building. So before that, we create architecture, the plan, right? So how we before we create a chip in the factory. So we just as a physical design engineer, we have to create a layout. So where how the chip size, what does the chip size need to be? Then how the pin gets placed like that. We are having some certain rules to design the chip. So once we finalize all the thing, like we will get a final GDS2 layout. That is what the final step, like GDS2. That is what we send it to the factory, and they will fabricate it. They will make a chip out of it. Okay. So these are the stages, like that's what I am telling. Like first stage is like the synthesis stage. That is where your main RTL code, that what you have written, that RTL that has been converted into the from behavior level to the structural level. Then from synthesis, like the next is like floor planning, where you can see define area, the IO pin placement. That is where you will create the size of a chip, like what actual size it need to be. The IO pin is like the input and output pins that here also, like you can see this board, like you have some pins like so to communicate, so that that now will give in the floor planning stage. Then the placement stage, so where we will place some a number of standard cells, like millions of standard cells will get placed. So each standard cells will perform a specific logic functionality, like any gate. Like if you come across, if you are in from a triple background, like you see, like you can know the basic gates like and not like that. So each thing performs some functionality. So that what we call it as a standard cells. So that will get placed in this placement stage. Then the clock trace into the stage is like we distribute the signal, like from the data need to be transferred to all the registers at a equal time, so that we won't get any timing issue. So that we will fix it in the clock trace stage. So once the input has been traveling, so that need to be traveled to all the registers at the same interval of time, so that we try to reduce it in this clock trace stage, like how we distribute the signal equally to all the registers. Register is nothing but like storing the memory where we stored. Okay, so that's what we do in the clock trace stage. Then the routing, where the actual connections will take place. The wire gets connects to the cells, that what I have tell you, like the pins and the IO pins, like those connections will get being placed in the routing stage. Then the next stage is like DRC and LVS thing. DRC is like design rule check. That is from the fabrication, like we have some certain design rules to make a chip. So we will after we generate the layout, we will just check the whether the actual design, like what we designed, is being similar to this DRC, like what we get from the foundry, so from the factory. That we will check. Then we will get the final GDS link. So that is what the final layout look like for the microwatt. That what we use. So the microwatt that has been from so that this is the final layout of this microwatt chip. So this has been developed from the 130 nanometer, the size of a chip. So currently, so to develop this layout also, so if you come across, you can see the names like Cadence and Synopsys. They were the major tools, like where currently the chip has been designing. But this has been like fully that is costly. So maybe some colleges may have some license, but students may not get able to access to the tools easily. But we have a similar tool called OpenRoad, which is an open source tool, which is similar to this Cadence and Synopsys, but with some limitations. Like not currently in the market, like we have some around 2 nanometer, like we are creating a chip out of it. But with this help of this OpenRoad, like we can able to make a chip around 45 nanometer. Right now, it has been possible. with this open source technology. So similar to that too, so that students can get in-depth understanding of in the physical design, like how we can able to create a chip with this tools like OpenRoad and all. Uh, that's how the from Internet so like what we developed from the RTL to the final layer. Do you have any doubt?
So in the meantime, Kirwan is discussing with the professor. I'll invite Visha ma'am to share about herself. She is an IT professional. She's currently doing a GenAI course with us. She'll share her experience.
Hi everyone, good evening. My name is Nishanti and I'm working in Cognizant and I have 14 years experience. This is my second TechMate with object automation. And right now I'm doing GenAI under the guidance of Rahul. And it is fantastic actually. Almost whatever he said here, I can able to, get all the things. So I cannot able to ask questions also because I'm the one used to torture him with so much questions. So even I mentioned the same to Ganesan sir. And I'm eager to know like what's happening here in object automation. That's why I'm attending the every TechMeet, even though this chip design is completely new to me. But still, I want to know what's happening around us because, as said, like AI is completely in, and actually there is a sir used to say, Ganesan sir used to say like. In future it will be like 1:500 ratio, like 500 resources will be replaced by single AI. So that's what I remember when you asked that question, sir. But still we are doing this presentation, like for example we are doing this presentation, this AI can create this slide in a few seconds actually, but still there should be a human intervention to give the prompt. So humans will remain, they will stay, but still AI do a major role. That's why now everyone is getting into the AI. And see, I'm standing here with 14 years experience in IT, but still I'm learning Gen AI today. So yes, sir. Yes.
You are doing GenAI.
Yes.
So you learn only GenAI. We don't need to learn other. It's enough to. It is advanced now.
Correct.
It is advanced. There are lower age or is available in the IT model. We learn only GenAI. It is enough.
See, at this point, it's I don't have answer for that, sir, because I'm completely doing this under the guidance of Ganesan sir, because I said about my background, like what I'm doing at my professional thing, and they is the one suggested me, and I can relate what I'm doing with the Gen AI. So maybe this is not a full stop. We have to keep learning. Actually, so many things are there. We have to keep learning.
What I know, Jenny is advanced
Correct.
at present. So after that, it's a reason. Jenny is a reason.
Correct.
So your working IT companies will be for like a professor like us. How it is in our profession, Jenny, in our job. So what is the role of Jenny?
Maybe you're from which background, sir? I mean, you're giving the lecture to which department?
Computer science.
Maybe answer to Rahul is a genius. You can do this.
Yeah, I can answer that question. So, yeah, you'll be preparing for the classes, right? So you can get notes from me today. Like, what can I do in the next session that could utilize the students? Like, in terms of what I can do in terms of theory and what I can do in terms of practice. So you can do planning kind of thing. Like, what can I teach so that I could utilize the students?
This agentic
Like
AI
what?
can do this.
Yeah. So what I can learn from that, and I can do to the students.
So it's like you no need to spend so much of your brain, sir.
For example, in our work curriculum, about in exams,
Okay.
department exams. So we have so many duties, 2 months
Okay.
in a seating plan, and
That's what, sir. AI will give all the things.
timetable for a lecture, these all things will be done by.
Yeah, of course. If you give the prompt, it depends upon your. What to say? The summary of things which you are going to do, that will be given by the AI. Sir. I am using almost all the tool Claude Copilot. Yes, of course, everything it does. So nowadays, even I asked this question to Rahul also. Like no one is doing the entire code, sir. Everyone is doing byte coding only. So still, we need to understand all the syntax, what needs to be used, all the things. But still, so everything, each and everything you can do with the help of AI, and we have n number of tools, and we got and. List of all the preparation things, what you have to teach on that particular day, how to give the explanation, and how students can get that information, how easy you can deliver them, everything it will suggest.
For example, for preparing notes, for video content, YouTube video content is
Okay.
for a problem. I understand the problem. I like to convert this video content to text content.
Okay.
That will do.
Okay.
Video content to text content.
Uh,
Sir, YouTube itself, the option is available. Gemini, there is have an inbuilt icon in the YouTube. Just you can click, it will generate the entire content which is available in the YouTube. I mean, which is available in the video.
Even this question also, to get the answer, we can ask the AI, sir. So that only we able to students to learn AI tools. So even now here, even a 6th standard kid is learning, sir. That's how it's coming actually now.
Like we are having to extreme academy of learning. So one more organization, object application system concern company. That students will be learning 6th grade onwards, like how to use the AI tool. Even like a 3rd standard onwards, the student can learn from hardware. The book will be there. DAV, the son is studying DAV. He is having the hardware. So that he can teach the students how the AI tools will be used like that.
These AI tools are free or have to pay any?
Like the whole
So, if you have, that like Geo is giving you Gemini, like if you will be having pro version, you can use Gemini as if you want. So when it comes to like ChatGPT, it can also give you much wider content, but it is limited to some content. Likewise, with Claude. So if you want, you can go with open source models. Like as I mentioned, you can have a local model running on your laptop, so you don't run out of model. So you can use those models for your educational content like preparing and so on. But if you want to learn from something from YouTube, or you want to browse over the internet and you want to have some data, you should go for ChatGPT or whatever the tool you
It's a normal process. You just log into the cloud and you can get the information. Sir. Just not a paid, sir. Not a paid.
Pro version is free.
Yeah, all the pro is paid, sir. Normal thing that it's a right.
Only limited things we can do.
Correct, sir. But we won't like see
Yeah, that's where prompt design comes in. So we should know
Correct.
what is the proper prompt we should give to the model so that it doesn't consume more tokens. So Claude, it gives you certain amount of tokens per session. Per session, it gives you certain amount of tokens. Yeah, one X exhausted, you have to wait 5 hours. So likewise, one session it can go around 300 or 400 K token about. But once it reach 200 K tokens, you should shift to an unused channel so that you don't consume heavy tokens. So likewise, we have some tips so which can utilize them.
It's completely like if you're done with the cloud, you can switch to Copilot, sir. And also the prompt, as Rahul said, it depends upon the prompt. Instead of asking what is this, rather we can give the subject actually, the entire subject. This is my need. This is what I need. So if you give the prompt in correct way, then we can reduce the time, sir. And also Claude, it's giving like if that period is completes, it's giving a 3 hours time interval. After that, you can again use the Claude. When compared others to me, I thought like Claude is good. ChatGPT, Claude is fine. Sir. That's it. Yeah. Thank you. At this moment, I just want to Ganesan sir for giving me this opportunity to attend this tech meet, also for guiding me till now. Thank you, sir. Thank you for that, and thank you, of course, Rahul. And
Thank you. So, thank you, ma'am. So, like Sir said, we are using Google Meet or Zoom Meet. So, transcription, those days, somebody has to transcribe. Now, for example, head of department is organizing a meeting with all the faculty members. So, they will be talking. So, now in Google, we have the AI assistant. So, whatever you are talking, it is getting transcribed instantly. At least with 90% accuracy, we can say. So, it will not say 100% accuracy. All these AI tools, it will not give 100% accuracy. 90% accuracy, it is saving a lot of time. Previously, one line of transcription will take more than 10 minutes to transcribe. So it is helping us, like Google, all these things. So like these AI tools are very useful to us. So anybody wants to share opinion? Yes, few words. Please.
So myself Vijay Kumar, so working in DM of Engineering, CS department. Yeah, fine. So myself Vijay Kumar, so I'm working in DM of Engineering, CS department. So 15 plus years experience. So this AI tools, I'm also using AI tools Claude. So for preparing Claude, notebook LM. ChatGPT, Copilot. So myself learning so how to prepare notes. In those days, preparing notes with each and every unit, I will be typing the notes. Okay. So now, so with the help of the YouTube content, the notebook, and I'm using a notebook, I can able to develop a PPT. So in those days, PPT presentation I will be doing manually. So it is learning. So by my own effort, so I have a eagerness to learn more because I think things which I have learned is only 10%. So there will be more thing about AI, so that I am able to equip in this profession. So and also I want students to share my knowledge of AI. So even I am not fulfilled with this. AI content, so I can't able to share anything to the students. So if myself is only 10% of doing these things, I cannot able to share to the student 1% also. If I know about this 100% only, I can able to educate students 100%. So it will be useful for myself as well as students. I am eager to learn AI. So because it is a future trend. So Sir said one thing I have answer for that. 650 students, 1,000 students, 650 students are CSE background, AML, and IT, or AI backgrounds. 350 is civil mechanical. I think in future, civil mechanical also want need AI. Civil mechanical and electrical, electronic. Now all the course, even English teacher also want the AI. Because nowadays they are learning English with AI. So AI is educating other than teachers. AI educating them. Speak easy and that is one app is available. So English teacher, even Tamil teacher, Tamil AI is also is there to learn Tamil. So even there is a Bible AI is also there. So it can educate like pastor. Each and every Bible content is educated to the believers. Because I'm Christian, so I'm learning like that. So in every field there is a, it's not left to one thing in religious, in how to develop the agriculture, everything. So each and every person's it is essential.
Okay. Thank you, sir. Thank you for your kind words. So, like to speak, sir? So, basically, yeah, okay. So, want to talk, you can come and talk. So, students, can anyone want to talk? Anybody want to talk? You share. So, you are talking. You are taking input from various sections of people. Like, one of the students can come and talk. So, you attend the interview board also. Go to attend the interview board also. You can share about that. And what is the purpose of coming here for the technique? So, what did you gain? You can share your thoughts. You can stand here. That's it.
Hi everyone. So I'm basically a second year CSE student, BTech AIML. So I'm going into third year, and I came here because I wanted to be a part of the company as an intern. And the tech meet I want to attend it to see all the courses that you offer, and it was a very insightful experience. I learned a lot, and I'm not very new to the chip world, and the little introduction was a good way to it. And I look forward to joining here to what is said.
So with this, we end this tech meet. So I thank all the professors, faculty members, students, all the other people, dignitaries who come here. Also my employees. Thank you very much. Thank you, sir. Which people, sir?
Edge computing and
Okay, I'm sorry. I'm sorry.
if it is possible, you ask.
I'll ask it. Shall we share? Yeah, sure. Definitely, it's possible, sir. It's possible. I will share. What are chip design, right?
Chip design and the edge.
Okay, 10A.